Mà mình ở đây mình không thấy sinh viên hả?
Dạ rồi, ok rồi đó này.
Ok. Uh, Hello everybody and welcome you all to Computer Network live stream class. My name is Lai Nguyen. I'll be teaching you this course for this semester. I have had my profile uploaded in previous video. So for any questions, you can drop me a message by email to live@hcmut.edu.vn. So for this course have 4 credits. So of about 45-hour lecture and 30-hour lab exercises. But now we reduce for about 10 class, around 45 10s. It means every week you have a course in live stream class, and the lab exercise will deliver to you each week. So pay attention to the assessment method. Here, the final exam, you will have a multi-choice questions about 90 minutes. The evaluation ratio is left 10%, assignment 30%, and final exam content 60% of the final score. So this course provide you a fundamental concepts in the design and implementation of computer network and the internet as illustration. So during this course, you will have the definition of protocols, standards, some network services, and application as you use in everyday life. This course also introduces you to the network programming via some assignment. You will have a 2 assignment during the 10 weeks. The basic network security is also raised in this course, as this is very important for the operation of the computer network and the internet. So the goals of the course is to build for you a basic networking knowledge and some concrete experience of the challenges when you have the design of the network, and some operation for the network in real time, in real life. You have some lab exercises for experience with the network design. So the core will cover some topic as the network architecture, some reference models used in network design, such as OSI and TCP/IP. TCP/IP is a protocol stack used for the internet. We will also make illustration, some common applications and corresponding application layer protocols, such as web application as you use every day with your computer, personal computer. This application use protocol called HTTP. Other applications are also commonly used for our internet, such as DNS, email, P2P, and CD and CDN. CNN. I will explain to you the CDN later in this course. So other topic covered by this course include internet transport, brokers, UDP, and TCP in occurrence. Some issues related to routing and internet working, internet addressing, routing protocol, and internet protocol. IP, as you know all the IP protocol used in the internet. Some technology used with the local area network or LAN, such as Ethernet, wireless network, Wi-Fi, and Bluetooth. So, two oral topics are also covered in this course, but briefly and basically, core network programming interface and network security. So the course are divided into around 8 chapters, but we will complete only 6 chapters. The first chapter discusses about computer network and the internet. It will be held today. In 2 weeks, I will introduce you the computer network and the internet chapter. For the next chapter called application layer. Here I will explain to you some application use such as web surfing, email, and FTP for file transfer, and a chapter about the transport layer. Pay attention that this course is organized in a top-down approach. It means that we will explore the layer closer to user is the application, and we take the down work to other layer until the link layer or land. Wireless and mobile network also very popular now, prevalent in our life. As you use your smartphone or PC with a Wi-Fi connection, so there is a chapter wireless and mobile network dedicated to some technology used with the mobile network. If we have a time, we will also discuss about the security in computer network and multimedia networking. To get a better comprehension and a good story to computer networking, you should read the textbook. The first reference, Computer Networking, a top-down approach, Jim Course, edition 7th edition in 2018. The two other references, the illustrated network, how TCP/IP work in a modern network, is a very practical experience on computer networking. You see that there are many exercises or many devices on the how operate a network. Other academic book use many years in the subject computer network, called Computer Network Are Returnable. It's a good reference for computer networking. So let's move on to chapter 1. I will introduce you the first few of the computer network and the internet. in this chapter. Firstly, we will have an overview of what is Internet, what is a protocol, and by studying the network architecture, we separate the network edge, including host, access network, or some type of physical media. In the other parts, we will also examine the network core services as some uh, essential parts of internet structure, and services the package or circuit switching as network core is implemented by ISP. So when we talk about computer network, we also mention the network performance, such as some criteria consider packet loss, delay, average delay, the throughput of the link, etc. And I'll give you the calculation method used for this measurement. In this chapter, I have also a brief presentation to some security attack, such as a virus, a worm, or a denial of service attack. Some common security in computer network. The last part is about the protocol layer. Why we layer the network structure. The layering structure have analyze the network easily, and some service models used in computer networks such as OSI and TCP/IP. So there is a fundamental question. It's easy to answer, but never is it never the correct answer. Is what is the internet? So the internet is imagine it as a connection of a lot of computing device and networking device following a structure. So the first view of the internet is not endpoint view. Let's see, we have a network illustrated in the figure. So there is some kind of network, a mobile network connect a PC with a Wi-Fi connection, a smartphone used by user the 3G or 4G connection, and some vehicle use also the wireless connection to get access to the internet. Other kind of network we call home network or residential network connect some computer at home or some appliances from home to the internet. Other also a very popular network is called institutional network, connect a company, an organization to the internet. So the networks connect to a network device and get access by supplied by an ISP. ISP is organized following a regional or global ISP. So get a closer look to some kind of network. The first network is home network used at home. So the network connect now a billion of computing devices. Uh, Before we consider that only the PC or laptop connect to the internet, but now many other kind of devices, such as now you can have a smartphone, some device or on in a car connect also to internet. So in the computer network jargon, computer device run network apps is called a host and or end system. Throughout this the course or as written in textbook, a host and end system is it used without difference. Okay, so a host or end system running a network application. Uh, so the host connect to networking device by communication links. There are many physical media using in communication links, such as fiber cable, copper cable, radio spectrum, or virus satellites. In the communication links, we consider the bandwidth. This is the theoretical value of speed of data transmission. So the bandwidth is different from a throughput on a link. Although two value is used confusingly in some cases. So bandwidth is the maximum value of speed characterized by the link or the physical media. But the throughput is a value measure in a time. So the third component in a network is a networking device. Networking device are function of forward the data package to the next hop or the next node in the network. There are two popular networking devices called routers and switches. Routers forward the package in network core. Switch are used in access network to connect some hosts to the router to form an access network. So here is some internet connected devices. As we see somewhere, internet phone, interrupter, monitor energy use, and some speaker really speaker connect to internet, and also IP picture frame. So now after have an overview of some component of the network, we can consider or define internet as a network of networks. There is a part of the network is an interconnected ISP, and other part called access network. The access network is defined as some computer devices relay or connect to a switch and this switch connect to the router. The first router connect to ISP. Other notion used in computer network called protocol. A protocol are rules that control the sending and receiving of messages. There are many protocols used in the internet, such as TCP, such as IP, HTTP, Skype, or okay. So uh, as there are many protocol used now, so many manufacturer of device or software can use the protocol to permit an interoperation of these device or software. It can is it necessary to standardize the protocol. Uh, the organization IETF, Internet Engineering Task Force, standardized almost the protocol used by Internet under the form of RFC, request for comments. Um, Statistically, there are around 7,000 RFC stored and managed by IETF organization. So, other view of the internet is considered as an infrastructure that provides the service to application. So the application, the network application run over this infrastructure, the internet. So now you see already the web, the voice over IP, email, the multi-person games, and e-commerce, social network. A lot of applications run on the internet. So internet service provide the service to the application. So to help the programmer to create an application, they also provide the programming interface. So a programmer can use some API, programming user interface API, to create the application. That application can run on the internet. There are popular API such as Java API, Python API, help to create network application. So a network protocol define the connection, how to connect to an entity from a distance, and define also the format, the order of messages sent and received among network entity, and also protocol define action taken on message transmission and how this this is acknowledged. It means that when the receiver receives correctly a message, it can have an acknowledgement or receive sent back to the sender. So network protocol are considered as the main brand of the network. It defines everything in the network, the operation of network application. So the network protocol is close or analogous to the human protocol. Here in the example, how the human protocol and computer network protocol use likely by exchanging the message between the entity. So, in summary, was the internet? Internet is considered as a network of networks. So there are three components of this network. The host, the host are the leaf on the network tree, and the communication links is a link connect the host to the networking device, and other component is the networking devices such as a router and switch. By examining the network structure, we will separate two part of two kind of network. Network H. Network H contain the edge system, access network, and links. And network core contain the part of packet switching, circuit switching, and some network structure in the core. Okay, let's move on to the network edge firstly. A closer look to the network structure. Network edge. Network edge contain host. Host is divided into categories: the clients and the servers. Clients require or make a request, a service to a server, and the server satisfy or provide some service to client or multiple clients. So clients usually on the PC or on the computer device such as smartphone or appliance in household. Server sometimes implemented or place it in a data center or in uh, a big room. So access network is also in the network edge category. Access network is defined as all hosts and system connect to the first router, and this router is released to other router of ISP by the means of wired or wireless communication link. So here we see also the physical media used to connect the host to networking device. The physical media divided into two kinds: wired, such as fiber or copper cable, and wireless, such as using radio spectrum or satellite. The network core used in the central part of the internet is implemented by ISPs. Network core interconnect the particularly only the router or switch uh, multi-layer switch. And network core is a network of network that we have a look on the internet. So I will give you a detail of access network and some physical media used for in this kind of network. So the first question here is how to connect a host or a system to an edge router. Edge router is the first router this access network connect to the internet. So there are some kind of access network: residential access network, institutional access network, and mobile access network. So as I mentioned already, in the network, keep in mind that how is bandwidth is used in this kind of network, and the bandwidth is shared or dedicated. So the first kind of network is a home network. Home network used at home use a DSL modem to connect to the internet. So there is this is a scheme to connect the home network to the internet. Here you see that there is a DSL modem. It placed after a blister because the DSL used the traditional telephone line uh, to get the access to the internet. So this blader can divide two kind of information. The first is the data to the network, and the voice to the telephone system. And the connection from the DSL modem to the central office or the telephone operator. In this link, the voice is later transmitted at different frequency of a dedicated link to central. Here you see another part of the central office called DSLAM. DSLAM is a DSL access multiplexer. It's connect or centralize all connection from the home, from the houses to a central office. And because here the network gives the same line for the voice or telephone and the data for for the network. So the DSLAM have a connection to the telephone operator network and the ISP. In this kind of network, it's your exiting telephone line until DSLAM. And on this line, there are data and voice. The upstream transmission rate is around 2.5 megabit per second, but typically of practically is under 1 megabit per second. And the downstream transmission rate is around 24 megabit per second, typically 10 megabit per second. But now with the new technology, this speed is much better than until the 54 megabit per second. So let's continue with the second type of access network. It's called a cable network. It's used on the line of television system. So if we have subscribed with the television operator or supplier, we can get also access to internet from this provider. So here on the cable connected from home to a cable head end or an office of the operator provider, on this cable practically this link is a coaxial link. Then on this link, there are a frequency division multiplexing. It means that on the same cable, Uh, they different channels transmitted in different frequency band, such as you see a bandwidth of uh, coaxial cable. There are 9 channels, 1, 2, 3, 4, 5, 6 for the video. It means for the television channel. And there are 2 channels for data, channel 7 and 8, and another channel for the control of the link. So now there is a diverse type of connection in the access network. So we can use a coaxial cable until the household, but there are some part of the connection that use the fiber cable. So it can help to speed up the downstream transmission rate until 30 megabit per second. And the upstream transmission rate is around 2 megabit per second. This kind of access network use a link, and this link is shared by the subscriber. Unlikely, the DSL use a dedicated access from the central office to the homes. So there are also another kind of connection. Here is an illustration of the home network. The home network connect some kind of PC, laptop, houses, appliances to connect to internet, and all the device connect to a networking device, a box provided by the ISP. So when you subscribe to an internet provider, they give you a box. In this box, there is some kind of modem. Uh, it can be cable modem if you subscribe to the television provider, or DSL modem if you subscribe to a telephone service provider. And the box contains also a router, a networking device to route the data from your home to the internet, and firewall or NAT, all kinds. This kind of device will be made clearly in detail in other chapter. So at home network, in home network you can have a connection, wired connection. If you connect, you plug a cable from your PC to the box or networking device. It can be wireless if you use a Wi-Fi adapter with your PC to connect to an access point. Uh, Here, practically now, all providers can deliver to your device content access point, content also a hook with 4 ports, and also a router, firewall, and NAT. So in enterprise, there is an access network really in a layer structure. It means that there are many kinds of topology used in a company, a campus, university. As there are many kind of devices, switches, used in the enterprise access network with different transmission rates. Now with the technology, the LAN technology, there are 10 megabit per second, but Ethernet now can obtain the 1 gigabit per second or 10 gigabit per second. So today, the end system typically connect to Ethernet switch before getting access to the internet. It means that the Ethernet switch really to the router, the first edge router, before getting to ISP router. So wireless access network. We use this kind of network without cable in any kind of device such as the smartphone, the laptop with a Wi-Fi connection, or in a car with a device for GPS, etc. So the wireless access network use the technology called Wi-Fi, and it is standardized by IETF with the course 802.11 BGNAC, and the speed or transmission rate are different from the core given by IETF. Another kind of wireless access network called wired area wireless access uses the telephone operation provided by telco cellular operator, and this can have a distance around 10 kilometers. So the technology gear now for the wide area wireless network is 3, 4, 3, and 5, 3 will be appear recently. So take a closer look to how a host can send a packet of data to another distant host. Firstly, a sending host take an application message. Here we call data from a network application in a message. So it break into a smaller package in Dragon, in the computer network Dragon in a package. So a blend L, and the sending host transmits this packet into access network at a transmission rate R, and the link transmission rate is a capacity or a bandwidth dedicated to this connection. How we can calculate the delay of this packet from the host to the first device in the access network. The delay calculated by the time needed to transmit L bit packets into the link. So here we have a L/R second used to transmit all the L bit or a bucket. So physical media. Here, all the unit used for transmission on a link is bit in any way. Bit is a unit used to transmit on a link, a physical link. A physical link is a link, a tie of cable media used to lie between the transmitter and the receiver. There are two kinds of physical link, a guide media and unguided media. The guide media is the signal propagate in a solid media, such as copper, fiber, or coaxial cables. Unguided media, the signal propagate freely in the air, such as radio spectrum. So there are many kinds of cable as we have seen already. The coaxial cable used in the cable network and fiber optic used practically in the network core. Now with the popular of FTTH, the fiber are also used in the home network, access network. So fiber optic can provide a high-speed operation and a very low error rate. Radio links types can be a terrestrial, microwave, a Wi-Fi, LAN, a wide area, 3, 4, or 5G cellular with a speed rate can be obtained 10 megabit per second or satellite.
Hình như hết rồi phải không?
Chưa.
Hả? Phải
Chưa.
không? Chưa.
Mấy cái 14, 16, 14, 14 năm.
Okay, so for the let's continue with the second part of the Ethernet architecture in the network core. Packet switching, circuit switching are detailed in this part. The network core kind of mess up internet connected routers. So here in the part of network core, you see practically only the router interconnected the ISP. So there are two services in this part of network. Packet switching, the host brick application message into packets and forward the packets from one router to the next router across the link. And its package transmitted at a full link capacity. The circuit switching will be detailed later. So packet switching uses a store and forward mechanism. Let's see an illustration for packet switching. If we have a host, this host sends a message to another host, a destination, after a device, a router. So the sending host build a package of L bit and send this packet to a link with a capacity R bit per second. So store and forward mechanism use entire packets. The packets have to arrive entirely at the router before it can transmit to the next link using the forwarding table from the router. So here, if the L bit received by the router completely, the router process the package to select an output and transmit this packet to the next link. The end-to-end delay is defined as the packets from the sender, the source, to the destination and received by the destination. So in the calculation, we can have an end-to-end delay equal to 2 L/r second. Here we assuming that the propagation delay is 0. In practice, the propagation delay is as the speed of the light. So packet switching. Here we so far we explore only the transmission delay, but there are many kind of delay, such as processing delay from the router or networking device. Queuing delays is in a buffer of a link, and some kind of delay propagation delay also. So queuing delay and loss are two criteria of the link when the router processes the package. So if arrival rate to a link assess the transmission rate of link or the capacity of the link for a period of time, a packet will queue. It means that the package will be stored in a buffer, a temporary buffer for this link, and wait until it turns to be transmitted on the link. And packet can be brought if the buffer, the memory are enough. So queuing delay takes some time also if there are many packets arriving to the router, but the output link have a small capacity. In the network core, there are two key functions for the network core: the routing and forwarding. Routing uh, is different from forwarding, but sometimes in many books, two functions are considered as the same. Routing determines source and destination route taken by the packet. It means that the router run a routing algorithm and result in a value in the forwarding table to have the routing design which output is appropriate for the packet to follow the source destination path. And forwarding is just an action of moving packets from router input to an appropriate router output following the forwarding table. In this illustration, in the figure, you see that if a package with the destination address arriving in the router and this router look up in the forwarding table, you see that this destination address correspond to the third route in the forwarding table. So the output link is appropriate is the number 2. And in the figure, this packet is forwarded by the router to the second, the link number 2. So routing, just the result of routing algorithm to determine the source destination path taken by packets. The forwarding is an action that moves the packet from an input to an appropriate output following the forwarding table built by routing algorithm. So there are two services for network core. The first service is called packet switching. The second service is called circuit switching. Circuit switching appear when the end-to-end resource allocated uh, to the reservoir connection. It means that there is one source and one destination. Firstly, before any data transmission, the disconnection allocates the resource. In the figure, if you see that there are two hosts, sender and receiver, make a connection, such as a call application. So the sender requests the first router reserve resource for this call. The first router asks for the second router resource, the second channel for this call. The second router resolve the resource with the third router with the channel number 4 for the resource until the destination. So the dedicated resources used for this connection is not shared for other connection. So they likely a circuit. Then all data from the sender issue the sender use this circuit to get until the destination. So the circuit switching is a technique used commonly in a traditional telephone network. In circuit switching, there are two kind of devising the channel. As you see on the figure, the first router resolve the resource with the second router on a link from first and second router. So the second channel in this link is reserved for this call. So there are two techniques used. There are three techniques used for the division of a link into channels. The first is called the frequency division multiplexer. Here you see that there are a link. If there are 4 users use the link, the frequency of this link is divided into 4 parts or 4 channels, and each user occupies 1 channel. So in the case of time division multiplexer, the channel, the link is used by one user in a slot of time. So the time divided into many slots, and each user uses a slot of time at an instance. Try to have a comparison between packet switching and circuit switching. Here, as you see, if we have a link with a capacity 1 megabit per second, users can use 100 kilobit per second when they are active, but almost inactive only 10% of time. So if we use circuit switching technique, 1 megabit per second link can divide into 10 channels, and each channel used by one user. If this link use a packet switching technique, this link can service more than 10 users. Here, for example, we can have a 35 user and properly 10 users active at the same time. So the circuit switching limit the number of users can transmit on this link, and the packet switching can have more user share the same link. So until now, we see that the internet social is a network of network. So end system connect the internet via access IP. So access network can be residential, company, or university, and the RSP provide access to access network can be residential ISP, access ISP. Uh, so the the structure of internet is very complex. The evolution sometimes driven by economic reason and national policy reason. Uh, Here's a picture from the ISP access ISP. There are a lot of access ISP, a million of access ISP in the internet actually. So how to connect the access ISP? There are many kind of structure used by you to connect access ISP to other kind, regional or global ISP. If we connect all access ISP in mesh, topology is very complicated. Uh, so there are global ISP connect the access ISP, but concurrence in service provided by global ISP. There can be some ISP structure. ISP can be divided into global ISP and institutional, in regional ISP. So in this structure, we define the peering link. The link relay the two ISP together before passing other super ISP. So their content provider network also use infrastructure from internet with the IXP, a point present internet exchange point. So here we see that a regional ISP connect to the tier ISP. So tier 1 ISP are some kind of ISP can relate regional ISP or access ISP. And Google implemented tier 1 ISP. So the Google can have a content provider network, a private network that connects the data center to internet, and usually bypassing tier 1. Here is the tier 1 ISP Spring operator in US. So in this tier 1, there are some point of presence, both connect and peering to other ISP. So the next section is about the performance criterion. such as delay, loss, throughput in the network. How we define the criteria? Loss and delay occur when a packet current in a router buffer. If the rate, arrival rate to a link, the access or output link capacity, the packets can be delayed or stored in the buffer. But if the buffer is full, it means that there is no room for the package. The package will be dropped, so the package lost. We are interested in the buffer of each link, the capacity of the link. We can reduce to the loss or the delay, the queuing delay. So until now, we see the propagation delay, the transmission delay. Now we can explore some other kind of delays, queuing delay with the buffer, the nodal processing delays on the node when the router process the package. So it can take sometimes, but typically less than millisecond. So what is the delay when the router process a package? It can check a bit error. It can look up in the forwarding table to determine the output link, and the queuing delay can be the time the packet stored in the buffer and time waiting, and propagation and transmission delay. All kind of delays constitute the delay, the global delay with a node. Okay, we stop here for this chapter, because this chapter will be held in 2 weeks. So the next week we will continue this part. Goodbye. Rồi. Hình như có cái má. Rồi anh tắt chưa? Anh tắt chưa? Hả? Tắt chưa? Chưa hả? Rồi. 10 phút nữa hả? Xin lỗi. Không nghe là ở dừng này. Ok. Sorry about that. Okay, we have 10 minutes left. Continue with the packet delay. So this is the formula used to calculate the packet delay. The packet delay at a node called a nodal delay. It can be calculated with the delay from processing of the packets, the delay the packets have to store in the buffer. The transmission delay is defined as how to push each bit from the packet to the link, and the delay from the bit of the packet propagate to the next node. But with this formula, sometimes the transmission delay and propagation delay, the transmission delay is sometimes higher than the propagation delay. So for the propagation speed, it can have around similarly to the speed of light propagation. We can neglect the propagation delay in the calculation of delay on the node. So queuing delay. the queuing delay is calculated at a transmit traffic intensity. So if we have a capacity of the link R and the packets have a length of L bit, the average arrival rate is R. So we can have an average queuing delay LA slash R. If this traffic intensity is approach closer to zero, average delay is small. But if this value approach to 1, the queuing delay is very large. And if exists the 1 immoral arriving, so the link can be serviced. Average delay on traffic intensity is a criteria considered when the traffic is congested or not. So in the internet delay, the real internet delays and the loss can be explored with the traceroute program. The traceroute is a utility for administration the network. When we run this program, we can have some kind of delay, average delay on the path from the source to the destination. So for trace route, it make for each step, each hop, 3 tentative. It send 3 packets to each hop and get the delay for each packet until it get to the destination hub. Here trace route with the address of GR CS UMass Edu. Here you see that there are the browser on the path such as CSG, W, or some kind. So there are 19 hubs between the source and destination. For each hub, there are 3 delay reported to the source. The in the 17 and 18 hop, there is no response because the router don't give a response to the request from the source. It's here delayed. We move on the packet load. The packet loss occur when the buffer on a link access the capacity, the memory. So the queue have no room for the new package arriving. So buckets have to bucket be brought by router. So the sender maybe retransmit the packet or not, following to the policy of or the protocol used by the source. So the third criteria for network performance is throughput. The throughput is the rate, the real rate at which bit transferred between sender and receiver. On one connection, the throughput is calculated from the source to the destination. So, sorry, now we can stop here and we continue the next part in the next week.